about triangle inequalities today. The big idea from this lesson is so simple. It literally says that the largest side of any triangle is directly across from the largest angle of any triangle. Okay? And then it would go, the middle side is across from the middle angle, the smallest side is across from the smallest angle. When I say across from, I mean literally like directly across the triangle. So if I start at my angle and I go whoop all the way across, I should get to the opposite side or opposite angle. Okay? That's the big idea here. Nothing crazy, nothing rocket science. What we are going to be doing is, given that information, can we list the angles or the sides from least to greatest? And then, of course, there'll be some solving in there as well. So, very straightforward. Example 1, list the angles from least to greatest. Well, if I'm trying to list the angles from least to greatest, I'm going to take a look at the sides. What's the smallest side? Well, the smallest side is AC. I would go across my triangle to the angle that is opposite AC. The smallest angle must be angle B. Not rocket science here. I'm going to continue that. The next smallest would be that side that is 8. So the next smallest angle across from it would be A. And then the largest side is across from the largest angle. 14 is across from angle C. Good there? Okay. So in number 2, it gets a little bit complicated because now we don't have a picture. I do recommend you start with a picture here. It helps. So I'm going to draw my triangle KLM. It literally does not have to look fancy. It's just a triangle. I know that this is x minus 4, LM is x plus 4, and KM is 2x minus 1. Now I need to figure out what are the largest sides, what are the smallest sides, because then my question asks me to list the angles from least to greatest. So pay attention to what it says in the problem, whether you're listing sides or angles. In order to list the angles, I need to know about the sides. It tells me that the perimeter of this triangle is, 27. So that means perimeter is when you add up all the sides together. When I add up all my sides, x minus 4 plus x plus 4 plus 2x minus 1, I should get 27. So I'm going to solve this for x. 4x minus 1 equals 27. 4x equals 28. X equals 7. From there, now I'm going to plug it in to figure out what my sides are. So 7 minus 4 is 3. 7 plus 4 is 11. 2 times 7 minus 1 is 13. We're not done yet. Now I have to go in and list those angles from least to greatest. So I start with the smallest side, which is KL because it's 3. So the smallest angle is angle M. The next smallest is LM. So that's across from angle K. And the next smallest, I pointed at the wrong thing. I should have pointed at the angle. But the next smallest would be angle L, of course. Is this making sense? Like I'm not doing anything crazy here. Yeah, we're good? Okay. All right. Number 3. How am I going to figure out what x is here? What formula do I need to set up for x? All of these angles, what? Anna? All the angles equal 180. So I can do 68 minus 2x plus 9x minus 4 plus 4x minus 16 equals 180. And then I'm going to skip some steps here. 11x plus 48 when I combine all my like terms. 11x equals 132. So x equals 12. Again, just like I did in that last problem, now I'm just going to go plug stuff in. So when I plug it in for each of these angles, 68 minus 2 times 12 is 44 degrees. 9 times 12 minus 4 is 104 degrees. 4 times 12 minus 16 is 32 degrees. I am listing the sides of ABC from least to greatest, so make sure your answer is in sides. What's the smallest side here? Caitlin? Yeah, AC, across from the smallest angle, which is 32, the smallest side is AC. The next smallest side, across from the 44, AB, which leaves that the longest one is BC. Any questions on that? Nothing crazy, okay? Look at the next one. If I just look at this diagram and I'm thinking, okay, smallest side, smallest angle, what do you think that the smallest side would be based on what the smallest angle is? I'm going to tell you you're going to be wrong, but just tell me what you think the smallest one is. What's the smallest angle in this whole diagram? The smallest angle in the whole diagram is that 50-degree angle, right? We see it? So it would make sense that the smallest side would be across from the smallest angle. So a lot of you are going to look at this diagram and tell me that it's DB. However, there are two triangles here, and the smallest angle overall does not necessarily mean the smallest side overall. So what I need to do is I need to compare both of my triangles. So I'm going to start with this triangle on the left here. I'm going to call this triangle 1. I'm going to list the sides of triangle 1 from least to greatest. So for triangle 1, obviously we think the smallest side is DB because it's across from the smallest angle. The next smallest one in that triangle would be across from the 59, so that's AB. And then the largest one in that triangle would be across from the 71-degree angle, that's AD. We're happy with that order? Let's take a look at triangle 2 and do the same thing. The smallest side in that triangle is across from the smallest angle, which is 55. So the smallest side here should be BC. The next smallest angle is across from the 60, so that's DB. And then the largest side across from the largest angle is DC. What do we see here now when I compare these two triangles? Do we see that DB, this one that I thought was the smallest, is actually the second smallest in triangle 2? So really, the actual smallest side should be right here. It should be BC. I need you guys to star this, highlight it, do something, because I guarantee you're going to forget to do this and you're going to skip to saying that DB is the smallest side because it's across from the smallest angle. When you have two triangles, you have to list both lists of all the sides out. Does that make sense? Hopefully, maybe. Okay. All right. Two big theorems we're going to talk about on the next page. Go ahead and flip over to it. The first one is the exterior angle inequality. I'm going to highlight this. Hopefully we remember from last unit our exterior angle sum theorem. Does anybody remember what that is? Maybe, yes, no. The exterior angle sum theorem tells me that the exterior angle, the measure of the exterior angle, let's call it exterior, is equal to the measure of the remote interior angles added together. I don't know what I'm doing here. Plus the measure of remote interior angle 2. That's my exterior angle sum theorem. That the exterior angle equals the two remotes added together. Now what we're saying, we're talking inequalities. It says that the measure of an exterior angle has to be greater than either one of the corresponding remote interior angles. And that makes sense, right? Because if I'm adding two angles together to get a third angle, that third angle obviously must be bigger than the other two. So in this diagram, remember to get an exterior angle, we take the side of a triangle and we extend it. So the exterior angle is angle 3. And all this says is that angle 3 has to be bigger than angle 2, and it has to be bigger than angle 1. That's all that says. Any questions on that? So when I look at this example in number 5, the exterior angle has to be the bigger one. So if I'm looking at letter A, angle 1 and angle 6, let me highlight where angle 1 and angle 6 are. This is my triangle. 1 is on the outside, so angle 1 must be greater than angle 6. What about letter B? I'm comparing angle 2 and 1. Which one has to be bigger? The exterior angle has to be bigger. The exterior angle is angle 1, so angle 2 is less than angle 1. I'm not doing any kind of rocket science here, right? All right, letter C says I'm comparing angle 6 and angle 3. Here's angle 6 to this triangle right here. Angle 3 is inside, angle 6 is outside, so angle 6 must be bigger. And letter D, again, angle 6 must be bigger, so I get a less than. Not crazy, right? We're okay? All right. This is the real fun part. I like this part. So it says, in order to form a triangle, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Put this in a highlighted box or star it or whatever you got to do. This is the big idea from this lesson, really. This says, no matter my triangle, if I add any of the two sides together, those two sides will be bigger than the third side, no matter what combination I put together. So in this example, I'm going to color code it nicely for us. Let me put some plus signs and greater than signs in here. So this states that if I add PQ, the red side, plus QR, the blue side, they must together be greater than RP. Let's pick a different combination. If I add together QR and RP, those two sides together must be greater than that red side PQ. And again, let's pick a third combination. If I add together RP and PQ, they must be greater than that third side QR. So no matter what combination of sides I pick, the two of them have to be greater than the third one. Make sense? So at number 6, it says, is it possible to form a triangle with the given side lengths? Well, I have to just test and make sure that all of those things are true. So I'm going to go ahead and I'm going to make a bunch of combinations of my angle measures, of my side lengths. 8 plus 15 has to be greater than 17, which it is. 15 plus 17 has to be greater than 8, which it is. And 17 plus 8 has to be greater than 15, which it is. I don't want to do that every time. What's a shortcut that I can use instead of plugging in all 3 different combinations every single time? Any ideas? I want to be able to test this in one step. I want to make sure that all of the sides, no matter what combination I pick, are going to be greater than the third side. Dahlia? Yeah, if I'm testing whether two sides are going to be greater than another side, I'm going to test whether the two smallest sides together are going to be greater than the biggest side. So really, all we had to test was 8 plus 15 is greater than 17. So make yourself a note. Test the two smallest sides together. So because the two smallest sides together were greater than my third largest side, I can say, yes, these 3 sides do form a triangle. Let's do the same thing with letter B. The two smallest sides are 6 and 8. Do 6 plus 8 make greater than 14? 14 is not greater than 14, so we would say no for letter B. Good? Okay. Here's the tricky part. We can figure out, is a triangle, or are 3 lengths making a triangle based on these ideas? What the tricky part is figuring out if I have two side lengths, figure out what are the possible values that I could have for that third side. So it says if the measures of two sides of a triangle are 5 feet and 16 feet, determine the range of the measures of the third side of the triangle. So let's call that third side X. This is a two-step process that you're going to follow every single time you do one of these problems. We are going to make two different assumptions. I don't know what X is, but I need to figure out what its minimum value could be and what its maximum value could be. At minimum, what does it have to be added together to be larger than that third side? So I'm going to assume that X is the smallest side. So if I'm assuming that X is the smallest side, to make a triangle, then it would have to add together with that other small side and be greater than the third side. So X plus 5 has to be greater than 16, which means if I do a little bit of subtraction here, that X must be greater than 11. Okay, if it is to be the smallest side, we know that the two smaller sides have to add together to be bigger than the third, so it's got to be greater than 11. Then my second assumption is that, okay, what if X is the largest side? Then my two other sides, 5 and 16, when I add those together, they have to be greater than that third side. So what is the maximum value that my X value could be? I add 5 plus 16 to get 21. So X has to be less than 21. If it is 21, then my inequality is false. If it's greater than 21, my two sides aren't going to add together to be greater than it. So two steps. Number one, you assume X is the smallest. Number two, you assume X is the largest. This tells me that X is somewhere in between, if you want to write it fancy. X is somewhere in between 11 and 21. Does that make sense? We're going to do the same thing in the last problem. Determine the possible values of X. Again, my missing side is X plus 1 here. Okay, it says it right here. So I'm going to first assume that that's the smallest side. So to assume that it's the smallest side, I add it together with the next smallest side. X plus 1 plus 5 has to be greater than that third side, which is 7. So X plus 6 is greater than 7. X is greater than 1. That's my minimum value. And then step 2, I assume that that's the largest side, so that the other two sides have to add together to be greater than X plus 1. So this is 12 is greater than X plus 1, or X is less than 11, sorry. Hello? There we go. Again, if you want to write this fancy, that would say X is between 1 and 11. Any questions on that? Okay.